Download this code from codegive.com, link in the description below. OK, let's dive into creating an input propagation chain in Godot, effectively managing how input events travel through your game scene tree. This is crucial for complex UIs, games with overlapping elements, and situations where you need fine-grained control over how input is handled. This tutorial will cover the fundamentals, provide code examples, and explain common scenarios. Consider this our episode 17 of a hypothetical Godot Basics series, building upon fundamental concepts. Core concepts: input events, signals, and scene tree structure. Before we get into the code, let's refresh some core concepts. Input event. This is a Godot class representing a single input action, like a mouse click, key press, gamepad button press, or touch event. When the engine detects input, it creates an input event object. There are different types of input events like inputeventmouse, inputeventkey, inputeventmousebutton, inputeventScreentouch, and more. Signals. Signals are Godot's powerful system for communication between objects. When an object emits a signal, any connected objects can react by calling a function, the signal's receiver. Signals are crucial for UI interactions. Scene tree. Godot organizes your game world using a tree structure. The scene tree is the root of the tree, and all your nodes, like sprites, buttons, labels, etc., are children, grandchildren, and so on. This structure is essential for input propagation. Godot handles input events through the scene tree. Input modes. Godot nodes have different input processing modes. The two most important are input mode. Pass the default mode. An input event is passed up the tree after being processed. Input mode. Discard the event stops propagating up the tree. No other node further up the tree will receive it. What is input propagation? Input propagation is the process of how an input event travels through the scene tree, from the node that initially receives it, often a control node, up towards the root of the tree. By default, when a control node receives an input event, like a mouse click, it first checks if it should handle the event itself. If it does, the event is consumed. However, even if a node handles the event, it will still propagate up the tree. This is key to how input chains work. You can however use except_event, to prevent the event from going further to other control nodes. The order of propagation is 1. The node that directly receives the event, example the button the user clicked on. 2. The node's parent. 3. The parent's parent, and so on, up to the root node. Why is an input propagation chain useful? UI interactions. Imagine a complex UI with overlapping elements. You might want the topmost element to handle an event first, but if it doesn't handle it, you want the element underneath to have a chance. Game mechanics. Consider a game where you click on an enemy to select it. If you click in empty space, you might want to trigger a different action, example move your character. Custom controls. When creating custom controls, you'll often need to intercept and modify input events before they reach standard Godot controls. Decoupling logic. Input propagation allows you to separate input handling logic across different nodes, making your code more modular and maintainable. Example, building a simple input propagation chain. Let's create a scene with 3 overlapping control nodes, each with a different background color. We'll demonstrate how to intercept mouse clicks at each level of the chain. 1. Create a new Godot project. Start a new project in Godot. 2. Create a new scene. Create a new 2D scene, or user interface scene. Rename the root node to main. 3. Add control nodes * add 3 control nodes as children of main. Rename them to control 1, control 2, and control 3. Arrange them so they are overlapping like layers. Set their layout/anchors and layout/offsets appropriately, so they fill most of the screen. 4. Add colors and basic size * add a color rect as children to each control node. This color rect will be the background. Set their layout/anchors and layout/offsets appropriately, so they fill the entire control node. Then set a unique color to each of them. For example, control 1 color rect, color, red. Control 2 color rect, color, green. Control 3 color rect, color, blue. Set all control node sizes to be the same, with a smaller one, a medium one and a larger one. Like control 1, size, 100x100. Control 2, size, 200x200. Control 3, size, 300x300. You should place control 1 on top of control 2 on top of control 3 so you can see all of them, by placing them near the center of the screen. 5. Create scripts * create a new script for each control node. Name them control1.gd, control2.gd, and control3.gd. Here's the code for each script. Control1.gd, attached to control 1. Control2.gd, attached to control 2. Control3.gd, attached to control 3. Explanation **** GUI _input, event, ***. This is the core function for handling GUI input events in control nodes. It's automatically called by Godot when a GUI input event occurs within the node's area. Inputeventmousebutton ***. This check ensures that we're only processing mouse button events. Event.pressed ***. This confirms that the mouse button was pressed down, not released. Event.button _index == mouse _button _left ***. This verifies that it was the left mouse button that was clicked. Print ***. This simply prints a message to the console to show that the event was received. Accept _event ***. This is the key to controlling propagation. When accept _event is called, Godot marks the event as handled and stops it from propagating further up the tree to other control nodes. If you omit this, the event will continue to propagate. Running the scene and observing the results ***. 1. Save your scene, example main.tscn. 2. Set the main.tscn scene as the main scene in your project settings, project settings application run main scene. 3. Run the project. Now, when you click on control 1, the topmost only control 1, mouse click received, will be printed in the console. Because you accept _event, control 2 and control 3 won't receive the input. On control 2, but not control 1 control 2, mouse click received, and control 3, mouse click received, will be printed. Since control 2 doesn't call accept _event, the event propagates to control 3. On control 3, but not control 1 or control 2 only control 3, mouse click received, will be printed. Advanced input propagation techniques. 1. Using input.is_action_pressed, or input.is_action_just_pressed, ***. Instead of directly processing inputeventmousebutton, you can define custom input actions in your project settings, input map, and use input.is_action_pressed, or input.is_action_just_pressed, to check for those actions. This makes your code more flexible and easier to remap input later. Example, define an input action called click. 2 inputeventScreentouch for mobile *. For touch events on mobile devices, use inputeventScreentouch. 3 modifying input events before propagation *. You can modify the input event object itself before allowing it to propagate. This might be useful for scaling mouse coordinates or changing the event type. Be careful when modifying events, as it can have unexpected consequences if not done correctly. 4. Using signals for input propagation *. Instead of relying solely on the built-in propagation, you can use signals to explicitly control the flow of input events. This can be helpful for more complex scenarios where you need to route events based on custom logic. The signal is then connected to any object, e.g. the main scene, that should respond to it. 5. Layered canvases *. When working with canvas layer nodes, remember that input is processed based on the layer's layer property. Higher layers receive input first. This is another form of implicit input propagation. Important considerations. Performance excessive input processing and propagation can impact performance, especially in complex scenes. Optimize your input handling logic to avoid unnecessary calculations. Carefully consider whether you need to process an event at multiple levels of the scene tree. Debugging use print statements, the debugger, and breakpoints to understand how input events are flowing through your scene tree. Input handling outside GUI * for input related to your gameplay, character movement, etc. You will usually use input.get_action_strength, function inside the underscore process, delta, or underscore physics underscore process, delta, functions and not using GUI underscore input. Complete example. Below the complete code for main, control 1, control 2, and control 3, as well as the project structure. Main.tscn, root node script. Control1.gd, attached to control 1. Control2.gd, attached to control 2. Control3.gd, attached to control 3. In summary, input propagation is a fundamental concept in Godot that allows you to create complex and flexible input handling systems. By understanding how events flow through the scene tree and using techniques like accept_event, and signals, you can build games and UIs with sophisticated input interactions. Remember to use the debugger and print statements liberally to understand the flow of input events, and to optimize your code for performance.